Upon arrival at the Alpha Wood factory, preparations begin for final installation. The same two cranes are set up again to lift the mill from the SPMT. The lifting process is carefully monitored, and the mill is slowly positioned over its concrete foundation. Riggers use guide ropes to help align the unit precisely. Finally, the mill is lowered and fixed in place with anchor bolts. This marks the successful completion of the heavy transport and installation operation. Meet Dolores, an SR's 1800 series bucket wheel excavator built in Germany. Stretching an astonishing 118 meters long and standing 38 meters tall, this colossal machine is a marvel of industrial design and engineering. Equipped with a massive rotating bucket wheel, Dolores continuously digs into overburden, removing large volumes in a steady, efficient manner. Its crawler-mounted chassis lets it move across mining terrain while the wheel spins to scoop earth, then deposit it via integrated conveyor systems. The bucket wheel excavator moves slowly along the bench, using its rotating wheel equipped with multiple buckets to continuously cut and scoop overburden material. As the wheel turns, buckets excavate the soil from the upper ledge, causing controlled collapse of overhanging material. The extracted material is transferred via conveyors for further processing or disposal. The machine maintains stability while advancing and adjusting its boom position during operation. The transport of a heavy reactor by Statnet began at Monstad Haven in Trøndelag. The operation involved a specialized modular trailer designed for oversized loads. After carefully positioning the reactor onto the trailer, the convoy departed the port, moving at a controlled speed to ensure stability. The transport route spanned through the municipalities of Afjord and Rouen, with support vehicles escorting the convoy to manage traffic and road safety. Navigating tight turns and uneven terrain required precise maneuvering and coordination. Along the way, temporary road modifications and adjustments to overhead structures were made to accommodate the reactor's dimensions. After a slow and steady journey, the reactor successfully arrived at its destination in Hofstad. This transport highlighted the logistical expertise required for moving large, high-voltage equipment through challenging infrastructure. The 4S50 MEX 9.7 research engine marks a major step forward in the quest for carbon dioxide neutral shipping. Built in South Korea and recently transported to the research center Copenhagen in Denmark, this innovative engine is designed to support the development of cleaner marine fuels. With a power output of 7,120 kilowatts, equivalent to nearly 10,000 bhp, this four-cylinder engine weighs 272 tons, measures 14 meters long, 7 meters wide, and 10 meters tall. Although powerful, it is considered small compared to the largest engines, which generate similar power per piston. Initially configured to run on diesel, the engine will be converted upon arrival to test alternative fuels including liquid natural gas, liquid propane, ammonia, and methanol. This flexibility is critical as researchers seek the most viable path towards sustainable maritime propulsion. The engine's journey included shipping through Copenhagen's harbor, being lifted ashore by crane of 185 tons, and transported by flatbed truck to its foundation. The entire project took approximately 2 years, involving extensive and adaptive design work to meet constantly evolving demands. The complexity of modern engine technology, compared to just a decade ago, means that development cycles are longer and more challenging. Therefore, having an additional research platform like this engine is essential for advancing innovation. Engineers faced final challenges during installation, including ensuring that the foundation remained stable as the massive engine was lowered into place. Once operational, the 4S50MEX 9.7 will play a central role in scaling up solutions to larger engines. Research conducted here directly supports the maritime industry's ambition to reduce carbon dioxide emissions by 40% by 2030 and achieve full carbon neutrality by 2050. This engine is not just a machine, it is a platform for progress toward a cleaner, more sustainable shipping future. The transport operation starts at the port of Kavala, where a 118-ton wood mill, measuring 21 meters in length and 5 meters in diameter, is prepared for handling. 2 large mobile cranes work in tandem to lift the mill off the vessel. The lifting is carried out with extreme care, using slings and spreader bars to balance the load and prevent damage. Once lifted, the mill is gently placed onto a self-propelled modular transporter with multiple axle lines for weight distribution. After securing the load, the SPMT begins its land journey to Nevrokopi. The convoy follows a carefully planned route that accommodates the large dimensions and weight of the equipment. Along the way, the team encounters sharp turns, roundabouts, and sloped roads. The SPMT's hydraulic steering system allows it to navigate complex road geometry. Support vehicles escort the transport at all times, coordinating with local authorities to control traffic and ensure safety. Upon arrival at the Alpha Wood factory, preparations begin for final installation. The same 2 cranes are set up again to lift the mill from the SPMT. The lifting process is carefully monitored, and the mill is slowly positioned over its concrete foundation. Riggers use guide ropes to help align the unit precisely. Finally, the mill is lowered and fixed in place with anchor bolts. This marks the successful completion of the heavy transport and installation operation. Once preparations are complete, the heavy cargo is carefully loaded onto the trailers. This stage is performed with high precision, using cranes or lifting equipment as needed. Once in place, the cargo is secured with heavy-duty tie-downs and hydraulic supports to ensure stability throughout the journey. The load is thoroughly inspected from multiple angles to confirm its balance and structural support. Safety teams double-check every fastening point, as even a minor shift in the cargo during transport could pose serious risks. With everything secured, pilot escort vehicles position themselves ahead and behind the convoy. These vehicles are equipped with bright flashing lights and warning signs to alert other road users of the oversized transport. Constant radio communication is maintained between the escorts and truck drivers to coordinate speed, positioning, and response to road conditions. The lead vehicle monitors the road ahead, ensuring that tight corners, bridges, or overhead wires will not interfere with the load's passage. The convoy then begins its slow and steady movement out of the yard. As the trucks transition onto public roads, they must maneuver through narrow lanes and around sharp curves. Thanks to advanced steering systems on the trailers, the rear wheels pivot automatically or hydraulically to follow the path of the tractor unit, enabling the entire load to navigate confined urban areas and intersections with minimal risk of collision or obstruction. The convoy travels across a range of terrain, from open highways to hilly regions. On uphill segments, the trucks rely on their powerful engines and low-gear torque to maintain momentum. On downhill slopes, engine braking and precision control are used to prevent excess speed and avoid overheating of the brake systems. Drivers remain constantly focused, making fine adjustments in response to changes in road gradient and weather conditions. As the transport approaches overpasses or bridges, precise clearance checks are conducted. The pilot vehicle in front provides exact measurements via radio, allowing the driver to slow down and maintain the safest possible trajectory beneath the structure. Often, the vertical clearance leaves only a few centimeters of space between the cargo and the underside of the bridge, highlighting the importance of route planning and driver skill. At scheduled checkpoints, the convoy halts for inspection. Technicians assess the condition of the securing systems, hydraulic functions, and tires. Drivers may rest briefly while support teams perform any necessary adjustments. These pauses are critical not only for safety, but also for compliance with transport regulations regarding continuous driving times and load monitoring. Continuing the journey, the convoy merges into general traffic. The pilot escorts ensure smooth integration by managing surrounding vehicles and keeping a safe buffer around the cargo. Onlookers often stop to watch or photograph the impressive transport, but the operation proceeds efficiently, with minimal disruption to the public. Eventually, the convoy reaches its destination, usually a construction or industrial site. The final approach requires delicate maneuvering as the trucks align the trailers with designated unloading zones. Using hydraulic systems, the trailers are adjusted to lower the cargo gradually and precisely. The trucks then detach, and the cargo is transferred onto supports or foundations prepared in advance. Eventually, the convoy reaches its destination, usually a construction or industrial site. The final approach requires delicate maneuvering as the trucks align the trailers with designated unloading zones. Using hydraulic systems, the trailers are adjusted to lower the cargo gradually and precisely. The trucks then detach, and the cargo is transferred onto supports or foundations prepared in advance. The entire operation, from initial planning to final placement, demonstrates the technical expertise and coordination required for successful heavy transport. Every stage reflects a Hola Special's dedication to safety, precision, and professionalism in handling extraordinary logistics challenges. On November 17, 2014, at 8 p.m., the transportation of the former 3-registered Ilyushin IL-18D aircraft fuselage began from Abdel to Kosache. The fuselage, measuring 36 meters in length, 3.6 meters in diameter, and weighing 20 tons, was moved in a single piece. The convoy carefully maneuvered through narrow roads and intersections using a specialized low-loader trailer. The massive structure was securely fastened to prevent any movement during transit. Escorts guided the transport, ensuring safe passage through urban areas and under power lines. After hours of nighttime travel, the convoy successfully crossed the Slovak border and continued toward Košice. The fuselage, nicknamed Moilona, arrived at its destination, the Slovak Aviation Museum. This marked the beginning of a new life for the aircraft as a museum exhibit. The entire process showcased precise planning and skilled logistics in handling oversized loads. On a Mamo at Lobel, the Kamasu PC8000 is meticulously loaded, cinched with heavy-duty chains, and escorted by pilot vehicles. The convoy shifts slowly, balancing weight and clearance. Expert riggers monitor clearances as the behemoth traverses roads, ensuring secure, steady movement to its destination. In this impressive demonstration, the massive T800 Bulldozer is tasked with towing a giant track dozer weighing approximately 120 tons. To distribute the load and reduce ground pressure, a large metal sheet is placed beneath the dragged vehicle. The T800, equipped with a powerful engine and heavy-duty tracks, engages gradually, building traction on the loose surface. Despite the enormous weight, the T800 manages to move the load steadily, showcasing its exceptional pulling power. Meanwhile, smaller tractors like the K700 and T130 follow, assisting slightly or observing the performance. The demonstration highlights the importance of weight distribution and traction in heavy equipment mobility. The T800's robust construction and torque output allow it to overcome resistance from the static load and friction between the metal plate and the ground. This demonstration not only proves the mechanical strength of Soviet-era machinery, but also illustrates teamwork among machines of different classes. Ultimately, the T800 successfully completes the pull, affirming its role as one of the most powerful bulldozers ever built. The ESH645 Walking Excavator is operating in the Reclamation section despite rainy conditions. This massive machine is designed to move without wheels or tracks by using a unique walking mechanism. To begin the step, the entire upper body slightly tilts backward while the walking beam lifts the base above ground. Then, the two support pontoons slide forward, acting like giant feet. After that, the walking beam shifts the main structure ahead before lowering it onto the new position. The process is repeated in cycles, allowing the excavator to slowly walk over uneven terrain. During the walk, the bucket and boom remain raised and idle for balance and safety. The excavator's task here is to evenly distribute the stored black soil chernozem across the site. This operation is part of a broader land reclamation process, where previously disturbed ground is restored for future use. Despite the rain, the ESH645 performs reliably, showcasing its capacity to function under challenging weather conditions.